to show you that we can also deal with fractions. We want to isolate x. The best way to isolate that is multiply something to both sides. So what do you want to multiply to both sides to eliminate that fraction? I want to multiply both sides by a 3. So in doing that, 3 times 1/3 is just 1. So I'm left with 1x, or just an x, is less than 15. And then I can graph that solution out graphically. We're getting used to that. Just draw my pivot point. My pivot point's 15. All my solutions are less than 15. And 15 is not a solution. So there we are, graphing that one out. Next example I want to show you is minus 3x is less than 21. Now remember, I said that our rules of solving a linear inequality are true for all the rules of solving a linear equality except for one. And this example shows you, or will be a demonstration of that example. It deals with when I have a negative, or when I need to multiply or divide both sides by a negative. So let's just do a little thought experiment with me if you don't mind. Let's come up with a true statement. Let's say 2 is less than 3. Do we agree that's true? Well, what happens when we multiply both sides by -1? Because it's one of our rules, when we multiply one side, as long as we do it to the other side. Well, what's -1 times 2? That's a -2. 3 times -1 is -3. However, which one is larger? If we can understand negative numbers, -2 is larger than -3. So notice what happened that I needed to do to the inequality sign? When I multiply or divide by a negative number, I have to flip the inequality sign around. That's the only difference from solving a linear equality as solving a linear inequality. So that being the case, now we can proceed with this problem. We want to divide both sides by -3, which is valid. We can do that. -3 divided by -3 just leaves with a positive x. On the right side, I have a -7, but I must flip the sign around for the exact same reason I did up here. I hope that makes sense to you. So when we deal with variables, we can still make sure we don't forget to flip the sign around when we divide or multiply both sides by a negative number. And then from here, straightforward, graph the solution out. 7 or -7 is my pivot point. All values of x greater than -7 are true. At -7, what's going on? -7 is not a value. So I put a soft bracket on that. Or again, my personal favorite is interval notation. And there you have a couple examples of how to solve a linear inequality, which are the same as an equality, except for one difference. And that was this difference right here.